My name is Michael with the Developer Relations team at Here, and with me today is
Hey, I'm Vidhan.
Avidon. So you also are with what company?
So I'm developer evangelist with Here Technologies, and I am based out of India.
Based out of India. So I
Yeah.
believe that we are almost quite, not quite exactly, but only off by a half an hour. I think the time here in Phoenix, Arizona is 7:30 a.m. in the morning. What time does that make it for you in India?
So it is exactly 8 p.m. in the evening. So we are two
Yes.
and a half hours apart.
Yeah, yeah, and I find that interesting. India is one of those time zones that has a half hour offset.
Yeah.
I didn't know that until we met the first time when we were in Mumbai. I'm like, oh, it's kind of strange that there's that half hour difference. But nice to nice to be with you on Twitch again. And you know what? For those that are watching right now, what's kind of interesting is we kicked off our AWS connection series last week. However, that a flavor, I guess, of AWS connections is all about supply chain. But this series, which will run every other week, is all about IoT. And Vidhan is taking the lead in explaining all these things. And let's find out why. Because Vidhan, give us some background. Like what's your background with IoT?
Okay. So I have worked on IoT when it started. I started working on IoT in 2013. So we never used to call it IoT. It was simply device-to-device communication, where we used to create a hardware with microcontroller and sensor and communication module, and then send the data to a server, which used to collect all the data, and then we used to pass it on to a mobile application or user application. But with time, things changed. A lot of new things came up, and everything changed. And then we started calling it IoT. So I have worked on that part. So I've seen the transition, and after that, I started. Uh, I was working as a consultant for IoT development, and then I also started being a trainer, a corporate trainer for training different companies and different, you can say that, uh, engineers on IoT, end-to-end IoT implementation. And that's my experience on IoT till now. And today we are going to talk about Internet of Things.
Yeah. Uh, I have to say, I only had a sneak peek, just a little sneak peek at some of the things that you were going to be doing in this episode. But I think that it's really great that I guess I didn't know if you said it specifically, but in your IoT background, ha- was any of it AWS IoT or was it another kind of IoT?
So earlier, we never used to have any of the cloud who is specifically providing services for IoT, right? So I think AWS started it,
Hmm.
and they started with AWS IoT, and they introduced a broker for IoT, right? So normally you have a server which we communicate using HTTP, but for IoT, AWS came up with a broker which works on PubSub architecture and uses MQTT protocol. So that is the first interaction I had with a cloud which specifically provides services for IoT. And now we have so many, and there's so many cloud service providers who are into IoT. So yeah, things have changed a lot.
It's true. I remember even at the beginning of, this IoT revolution years ago where uh, there was such a drive because of all the complexity to drive all these independent vendors even were coming up with these solutions to try to make things simpler and easier to do. So I think it's very cool that it has expanded to the extent that it has, where of course some of the major developer ecosystems are fully supporting IoT. However, even if someone is has just joined for the very first time, and for the sake of just we keep saying IoT and they don't even know what that means, just in case, how would you, in just a brief sentence, how would you describe what that is?
So it is Internet of Things. As the name suggests, it has internet and it has many things. And things are nothing. These are your small devices which are connected or which are everywhere. It's like these devices are at your home, like your coffee machines. These devices, when you connect to your coffee machine, they make it smart. You have smart coffee machines. Similarly, these devices are everywhere and they are connected over internet to either to one another or to a certain cloud, and they are interacting with each other. They are interacting with us. Say you have a coffee machine and it's a smart coffee machine, it will be interacting with you on your mobile application. So this is smart or intelligent network of devices who are communicating with each other, sending data continuously, and finding out insight from the raw data that we are sending is basically IoT, Internet of Things.
Cool. So, I believe, if I recall correctly, that you did have something that you might want to share in terms of like a presentation. Do you want me to go there now?
Yeah, please.
Okay.
So I have created a presentation just to explain you what IoT is,
Okay.
the architecture basically, and the device structure.
Cool. All right. So we're looking at a blank screen right now. Oh, there we go.
Okay.
IoT endpoint.
So in IoT architecture, we basically have four components. On the one end, we have IoT endpoint, or what we call IoT device.
Oh.
And it is the part which is on field, right? It could be in your home, it could be in your office. You could be wearing it right now as a wearable. And what it does, it collects the data, right? And after collecting the data, it sends it forward to another device or your mobile application or to a server. Example is your wearables, right? Wearables collect your temperature data, your heart rate, your GPS data, locations, and
Hmm.
then it sends to your mobile application, right? Okay.
Are there any other examples you can think of? So those were good ones. Like, obviously, we care about GPS because we're in location business. And you mentioned like heart rate. What are some other ones that are interesting that you've learned about?
So the one which I actually enjoy working on is industrial IoT implementation, where we have devices which are connected to your machines in smart factories,
Hmm.
or devices connected to those machines make the factories smart, right? And there, what we do is we collect data, for example, temperature data, humidity of a
Oh,
machine,
yeah.
vibration of a machine. So if your machine is vibrating a lot, that means that there's something wrong with it, right? And then complete those data is sent to another machine, a huge server, you can say that, in the factory premises only. And there you can perform all sort of data analytics, like predictive analytics, where you can predict if your machine is working fine or not. So that is one of the amazing example that I find I like a lot. Yeah.
Nice. Okay, I was just curious because I know there's a lot of different things, and by the way, those devices, even though they might be collecting data, I'll tell you, like my very first experience with an IoT device was not only can it send data to a place like we're talking about, but it also could effectively be a communicator, like for example LED lights and things like that. So would this still be at this IoT endpoint that you're talking about?
Yeah, so we'll dive deep into it when I'll be explaining you about IoT device, right? I'll explain you the different components which are involved in making an IoT device.
Cool.
And then we'll talk about LEDs, which is basically an actuating entity, or
Oh.
uh, we call it actuator, which is not a word, but a slang in a way. So we'll talk about that.
Very cool.
So
So it's all like you said IoT. So there's this internet component, and so apparently there's some way that these things are going to be able to communicate uh, to the internet. So does that lead to like what might be next?
yeah, so ideally the term is internet, but it's not necessary that you would want to connect your IoT device to the internet, right? But with the emergence of cloud and with the situation that we have with regarding security, the cyber security, the data security, we tend to involve internet where we are monitoring our devices. Let's say that your device is something somewhere on the move, or say in a truck where
Mm-hmm.
you are monitoring the truck, or it's in a rainforest where you are capturing the information about the weather, the rainfall, and all those things. In that scenario, you would want to connect it to internet, right? So that you can monitor it from your home or from your office. So,
Okay,
yeah.
that makes sense.
So in this architecture, first of all, you should understand this that IoT does not have any legacy based architecture, right? Or any architecture like OSI model where you have 7 layers and it's well defined and you can implement that particular architecture. It is something that you can work with, you can edit, and you can make your own one so that you can implement it in your business use case. So I'm going to explain a very open architecture which covers all the parts that are required in IoT. So first part is IoT endpoint, which could be your wearables or it could be smart machine, smart coffee machine. And then this data goes to a bigger machine, right? See, you can send the data directly to the cloud or directly to the user interface, like you do in variables, where your uh, variable is sending data to your mobile application. Mobile is your user interface. Or you can send data directly to the cloud, where your coffee machine is sending data to the cloud. Or another way is that, say, you are in a smart factory and all the machines are connected with IoT devices, they have IoT devices, then in that scenario, you would want to send all the raw data that you have collected to a centralized local server or a machine which is quite powerful. And that is what we call IoT gateway. And normally, IoT gateway could start from a very small computer, like a single board computer that you can see on your screen, which is called Raspberry Pi. And we'll be using Raspberry Pi to create one. So I have a Raspberry Pi with me. If you can see it, let me know.
Oh, yeah, that looks good. Yeah.
So we are going to use this to create a gateway. The major role of gateway in IoT is what we call protocol conversion. When I say protocol conversion, let's say that your IoT device is sending data in terms of Bluetooth to your gateway, right? And your gateway want to send this data to the cloud. So obviously your data is going to be in HTTP format. So now gateway will convert that Bluetooth data into an HTTP format. So that is one of the biggest role of any gateway. So that is the definition of a gateway, which is basically a protocol converter. On your gateway, what you can do is you can perform a lot of things, like you can perform data analytics, a basic one, because you might not want to send all the raw data to directly to the cloud, right? That would be too much. So what you want to do, you would want to filter out your data, raw data, and you want to send some contextual, concise, precise data to the cloud. So from gateway, that data goes to the cloud. Let's take an example of smart factory only, where you have IoT device attached to a machine, and machine that IoT device is collecting data like temperature, humidity, and vibration. And you have thousands of such machines in your smart factory, and all that data is going to your IoT gateway. Now, what is going to happen on IoT gateway? IoT gateway is going to collect that data. There could be a code running on it, which is going to segregate the data, which needed to be sent to the cloud server. And then IoT gateway is going to forward this data to your cloud server. And cloud server is where your major magic happens when it comes to IoT. You can perform all kind of tasks like data storage, data aggregation, data analytics, and machine learning, all those things. Or if you want to monitor your IoT endpoint from anywhere in the world, you have to involve cloud in here. Okay. And then from the cloud, what you can do is you can say you are a factory manager or you are an owner of this smart factory. You would want to monitor all your machines' health on your mobile or at your desktop, right? So in that scenario, you can simply get that data from the cloud and monitor all those things on the user interface or user application. It could be your desktop application, it could be your web application, or it could be your mobile based application. And the flow is not going to be only one way, the flow can be both the ways. It's to and fro movement of the data. The only thing changes is from IoT endpoint, you're sending the raw data to the gateway. From gateway, you're converting data into information, and that information is reaching the cloud. And on the cloud, you're performing all sort of analytics and machine learning task, and you're converting information into an insight which you want to have or which you want to send to your end user. So that is a flow of a complete IoT data, and this is a superficial, or you can say that a complete architecture of IoT.
Gotcha.
One more thing which is quite interesting to know here is that this architecture is not the only implementation. As I told you that we can have any kind of implementation here, right? Instead of me sending data directly or to the gateway, I can have a scenario like your scenario, for example, in your supply chain, right,
Mm-hmm.
Michael, where you're sending data from a transport vehicle, right? You're capturing all the data from a transport vehicle. Then you would then you would not want to send it to a gateway because it's not in a certain premises. You would want to send it to a cloud. So in that scenario, your gateway will be out of the picture, right? Your data will go to the cloud, and from cloud it will go to your user application. Another scenario is your variables, where we are bypassing both the cloud and the gateway. Your IoT data is directly going to your mobile application, and then from mobile application, it is going to the cloud. Another scenario is that you might not want to involve cloud also. You're simply sending IoT data over the Bluetooth or any other protocol to the IoT gateway, and then you're performing all the analytics on the IoT gateway. And from there, you're sending data simply to your user interface or user application.
Right.
So it is quite flexible, you can say that, the architecture. And as I said, it depends on your business case, your use case, what you want to build. And that is how you can build an architecture.
Yeah, I'm glad that you explained that because uh, that's what's kind of awesome is that everybody will probably have their own unique scenarios and for example, some of my IoT experience was like the latter of what you said, where there really wasn't any processing happening in the cloud at all. The IoT actually uh, literally went straight to the web client. I mean, literally, it was a straight away. And then from there, perhaps maybe a call was made to some server side processing. But it is kind of interesting. It doesn't have to go in a particular direction.
Yeah, and what is more interesting is that with the emergence of Internet of Things, the way in which data is flowing or the format of the data has changed, right? For example, from IoT gateway to cloud, if you imagine the format of data, then you will think about HTTP, Hypertext Transfer Protocol, that is secure, right? But one of the thing about HTTP protocol is that it is meant for us, mostly for humans,
Hmm.
where we are searching on a website, where we are simply writing the complete URL, and then we are attaching the uh, key value pair data, right? So what it does is it increases the data size, and in IoT, you does not need that. You you are not supposed to read that data. This data is for machine. It's not human to machine communication or machine to human communication. Mostly, you'll see from IoT endpoint to gateway to cloud, this is completely machine to machine or device to device communication, what we call M2M. In that scenario, if you are going to rely on HTTP protocol, right, that is going to consume a lot of bandwidth, right,
Right.
and your overhead will be a lot, and you might get a lot of bill on your cloud also, right, because you're sending a lot of data to the cloud. So to solve this scenario, what we do is, or what has emerged is what we call MQTT protocol. That is message queuing transport telemetry. I think I got it right. And this protocol works perfectly with an architecture which is called publish subscribe architecture, right? So it's like if you compare with HTTP, then you have HTTP versus MQTT, and HTTP works in client server architecture where you have a lot of clients like your laptop, and you have server like, say, any server, and you simply keep on pinging that server asking for the resources, and the size of data that you're sending to ping the server is huge, right? And you're totally dependent on the server, and you being a client, you have to be very, very, very active. Now, we can afford it on a laptop or on a mobile. Why? Because they have huge resources. When I say resources, I'm talking about the processing capabilities, I'm talking about the battery life. But when we talk about IoT devices, right, they are resource constrained devices, right? These are small devices. For example, let me show you one of the devices that I'll be showing today.
Cool.
It's somewhere, yeah. I have a lot of cluttered devices sitting here. So this is one of the size of a microcontroller. This is a
Uh-huh.
prototyping board. And if I imagine this particular device sending data and again asking for resources, it is going to consume a lot of processing capability, and it is going to consume a lot of battery. And that is something that we don't want. So what we do is we move to publish subscribe architecture. In this architecture, your client, which is publisher and subscriber, they are not that active, right? Instead, your cloud is active. The cloud or the server that we called broker in PubSub architecture. Your broker is very much active. In that way, what happens is you don't have to ping again and again. You don't have to be online all the time. So that saves battery on your device end, one. And second, the protocol that we use here in publish subscribe architecture is what we call MQTT protocol, and the size of this protocol is very small, right? You don't have to have overheads, right, like we do have in HTTP. So what it does is it also saves your battery and processing capability. Now your IoT device can totally rely or totally do what it is meant to do, that is collect the data from sensor, do a small processing of the data, and then forward it to the gateway or cloud or to the user application. So that is something very interesting about IoT architecture, which has changed with the emergence of IoT.
Oh, cool.
Yeah. Okay. So next thing that we are going to talk about is, which is today's major theme or today's title is IoT device. Now, I like to give the examples where we can connect. So you can imagine IoT device as a human body, right? And human body has different components. Similarly, IoT device has different components. You can imagine we have a brain, we all do, right? IoT device also has a brain. And let's take an example that it's too hot outside and you're standing outside. What are you going to do? Your skin, which is a sensory organ, is going to capture all the temperature data, right? And if you are feeling hot, that temperature data is going to reach to your brain, and your brain will process it, and your brain will decide if it's hot or not, right? And if your brain decides that it's too hot to stay outside, what's going to happen then, Michael? You're going to run, right? I'll run definitely, right? I'll run for a shade.
Right.
So that running done by my legs or by my hand, right? If I'm an animal, right? Uh, then that running is done by our legs and hands, right? Those are the parts which we call actuator or actuating entity. In IoT, we have analogous to this like LED, which is something called action showing or taking entity, right? Okay. Similarly, what you want to do is you would want to tell your friends, your families that don't go out, it's too hot. So we are communicating, to and fro communication or full duplex communication happens with our mouth and our ear. Similarly, in IoT, we have communication entity. So let's talk about the brain first. So brain of any IoT device is its computer. Now, the computer that I'm talking about is not your laptop or desktop. Okay. These are your small computer, which we call microcontroller, like this. Or you can have different microcontrollers like this, which is at Mega 2560. Right. So we have a lot of different microcontrollers from different companies, like you can read on your screen, like Texas Instruments, or NXP Semiconductors, or Microchip, or Cypress. There are a lot of different companies who create a microcontroller, MCU, and these are of very small size. And since these are of small size, they have small processing capabilities, they have small storage, and everything is small, right?
Right.
Okay. Now, what we do is to create an IoT device, first and the foremost thing is you need to have a microcontroller. And then, for example, this is a microcontroller that you are seeing on your screen is by Texas Instrument. This is, I think, uh, CC series microcontroller, Simplink. And then you connect a sensor to it. And sensor, as we have eyes and ears, sensors are basically the entity in a IoT device who collects the data, right? And these are like our sensory organ, like our skin. It collects the data from your surrounding. So we actually collect the contextual data from an IoT device.
Mm-hmm.
And these sensors could be your analog and digital. Analog is something which is changing with respect to time continuously, right? Like temperature, it varies from 0 degree or minus or 0 Kelvin to 6,000, 7,000, any Kelvin, right?
Sure.
So that is analogous. And then we have real sensors, which are simply going 0 and 1, 0 and 1, just like yes or no.
Yeah.
And all these sensors are basically kept in these two categories. And what are the things you can sense here?
Uh-huh.
Obviously, you can sense things more than what we sense as a human. We can sense temperature, GPS, which is something that I have with me right now, proximity that we use in the cars, autonomous cars, if some car
Mm-hmm.
is near to you or far to you. Humidity, you want to sense the humidity, vibration, you can sense different things. I have a bunch of sensors with me, and I can show it to you.
Cool.
We are not going to use all of them. Which sensor do you like, Michael?
Well, first of all, with regard to your temperature analogy, Rawthorne mentioned a good point in chat that I think I was thinking too, especially living in Phoenix, Arizona. I don't know if my brain would tell me to run to the shade, but I might walk slowly, or I might even try to dive into a swimming pool. uh,
That's
uh,
an option.
but I think that boy, some of the sensors that I've really thought were interesting were either ones that like did altitude, GPS, obviously for a job, or even like temperature. So those are some of my favorites.
Okay, so I have few with me. So this is a proximity sensor,
Okay.
infrared base. So just to give you an idea of how big these sensors are, how they look.
Uh huh.
Now this is a complete assembly, right? The only part which we work with is this tiny part, if you can see here, the black part, squarish.
And let me ask you a question on that device. So at the beginning, you were talking about IoT endpoints versus gateway. Is that an
Yeah.
IoT endpoint?
So this is basically a sensor which we use to create an IoT device.
Okay,
This is just a
gotcha.
sensor.
Okay,
Okay. So we are in the middle of creating an IoT device, how to create an IoT device.
right,
So we have talked about microcontroller,
right,
which is the brain of IoT device.
right.
Now we're talking about the sensor. Then we have read sensor,
Uh huh.
which is basically for detecting the metal, I suppose. I don't remember it. Then we have ultrasonic sensor, which is again for proximity. And of course, we have GPS sensor for getting the latitude, longitude. It's on right now.
And
It
when
has
you
the
say
antenna.
proximity, by the way, are you talking like motion sensor type stuff, or what are you talking about by proximity?
Yeah, proximity as in if something comes in front of it, say for
Yeah,
example, this is a sensor, if something comes in front of
right.
it, it's going to detect it. So it's going to send the infrared,
Mm-hmm.
it will bounce back and will get detected by one of the LED.
Gotcha.
Yeah, and it will complete the circuit and it's going to tell that, okay, there's something in front of it. Similarly, this ultrasonic sensor is going to send the ultrasonic waves and will get the response. If it gets response, that means
Mm-hmm.
that there's something in front of it.
And will
So
it give things like distance of thing in front, or could some of them do that?
yeah. So basically, if we get the time, see, obviously we are going to get the time and how much time this is coming back. We can calculate that,
I
and
see.
we know at what speed this travel
I see.
ultrasonic.
Mm-hmm.
So you have speed equals to distance upon time, right? You
Cool.
can get the distance.
Nice.
Yeah. So that is what we use basically in most of the cars. This is a very simple one, a cheap one, but
Mm-hmm.
a very sophisticated one in your new age cars.
Hmm.
Okay, so we have an IoT device where we have to have a brain, which is microcontroller. Then we have to have a sensor. One of the sensor that we are using is what you can see on your screen is GPS sensor. And
Right.
then we have something which we call communication or communication entity. You would want to communicate, or your brain or your microcontroller is collecting data through your sensors. And then what would you want to do with that data? You would want to forward it to your gateway or cloud or user application. And for doing so, we need to have a communication entity involved here. And there are a lot of different communication entities that we get. The one that we're going to use is what we call GPS. Sorry, we're going to use Wi-Fi, right? And apart from that, you have something called Bluetooth also. This is one of the very old model, which is called HC05. And we have a lot of different communication entities, and they vary, right? We have short range, mid range, and long range. And
And
another,
so you were talking about all this like a human body, and so I followed you
yeah,
so far. We have the brain, we have
yeah,
the senses, which can be touch, taste, hear, smell, all that stuff. So communication, what would you equate that to in this human analogy? Is that just our talking?
Okay, if I compared with me, if I feel hot, I'm running, I'm going to scream.
Okay,
And
so your
everybody around me is
voice.
going to know that I am in pain. So yeah,
Right, but
and
if you
screaming
wanted
is,
a really long
yeah,
range, you might even do a broadcast.
exactly.
Something. Right.
So
Okay.
yeah, okay. So when we talk about communication entity, then you have short range, you have mid range, you have long range. And when you talk about short range, you talk about NFC, right? You must have seen in many of the mobiles that you have NFC sensors or NFC communication, where
Yeah.
you can keep both the mobiles near to each other and they will exchange the data, right? Just a to and fro data communication happens, and which has range in I think centimeters. And then you have RFID that you'll see a lot being used in supply chain, right? Where we are storing your assets in a factory, in a warehouse, and you have people carrying a gun kind of a thing, a temperature gun, where they are scanning all the boxes. So that is basically your radio frequency identification, RFID, which is used a lot in today's industry, right? In logistics and storing the goods and maintaining the inventory of those goods. And then you have Bluetooth, which again comes under short range communication, where you get the range of around few meters to around 50 meters, depending on which technology you're using of Bluetooth. So if you're using Bluetooth 5, 5.0, which is the latest one, it can give you a range of around 100 feet. That is what I have heard. I have not tested it. So don't take my word, try it out. And similarly, if you talk about mid-range communication, then you have your Wi-Fi, right? Okay, Wi-Fi, you can have a radius or a sphere of communication where you have a range of say 30 meters, right? That is the minimum, I think. And then you have Zigbee. Zigbee is very much famous in home automation or smart homes, where we create a lot of things with Zigbee communication. Then you have six low power personal area network, which is basically creating a personal area network based on your internet connectivity. So these are your mid range. There are a lot of different technologies which are involved here or which are there, but these are the major ones. And then when you talk about long range communication, first I'll talk about cellular. You have your cellular one, where you basically talk about SIM modules. I think I have one here somewhere, which I can, yeah, I got it. So you get something like this. It's a SIM module. Now it's a bulky module because mobile phone consumes a lot of battery, right? And this
Yeah.
also consumes a lot of battery. You can simply insert a SIM here and you can start communicating with this. And you can have 2G, 3G, and nowadays you also get eSIMs, embedded SIMs, which you can use and works very well. And most of the new age IoT implementation, which are there in transport vehicles, they use eSIM based communication modules, and that works well, right? And now we are going to have 5G, so that is going to be amazing, right? Uh,
Yeah.
Apart from that, the one which is quite interesting and I like a lot is LPWAN, Low Power Wide Area Network. Have you heard about LoRa, LORA, or Sigfox?
No.
So these are a very impactful and effective way of communication, long range communication. So LoRa stands for long range, LORA. And Sigfox is again the same thing. I think Sigfox was created in France. And the good thing about LoRa is that without your internet connectivity, you can communicate from one end to another, and the distance of communication is in kilometers. Now you can imagine it.
Do you know how many kilometers it would be?
Uh, Depends on the module that you're using. Let's say that you are using a Doji based module, then it could be anything. If it's an open line of sight, it could go from 5 kilometer to around 100 kilometers.
That's amazing. Yeah, that's
Yeah.
so I've never heard of that. Hmm.
Yeah, so that is the power of low power wide area network. It's based on CSS, that is spectrum, which is the modulation technology that we use for radio frequencies,
Cool.
and it does not get impacted by the Doppler effect. So that is one of some of the technicalities. So that means that if the signal goes far, they don't get to diminish that easily. They travel. So we have LoRa, we have Sigfox, and these are the amazing communication technology that we are using a lot in nowadays IoT device creation.
Gotcha.
And lastly, we have actuation or action taking entity. Now, you are collecting the data, temperature data, you are sending it to your microcontroller, and you're communicating it further, but you want to see if your device is alive or not, right? You would want to see. And for us, the best way of seeing this is if something is blinking, right? Otherwise, we won't know if device is on or off, including our TV, our AC, our everything, right? So this is LED, which is highly and mostly used, you can say that, actuation entity in the world, just to display what is happening. So something action is happening.
And
Another
I'm
actuating,
assuming, by the way, I'm
yeah,
assuming that the reason why it's something as simple as LED is also we could have a screen, we could have a lot of fancy things, but the LED is probably going to have the lowest power consumption compared to some other ways. Is would that be correct?
yeah, LED consumes almost no power. Right? It does consume, but uh, it is suggested that you should not have much of the LEDs on your device. So if you create an IoT device, for example, this one, this is just a sensor, right?
Mm-hmm.
This is your GPS sensor, and you can see an LED blinking on it. Can you?
Can you put a little closer?
So this is a LED which is permanently on here,
And I don't
red
see
color.
it blinking.
Okay, maybe
Where
because of
should
the
I be
color.
looking?
You should be looking here.
Oh, okay. Let me take a look at that spot.
Um,
Put a
it might
little
take time
closer.
to. Okay.
Uh, I, well, others might see it. I don't know if I see it,
Yeah,
but
I'll show it. I'll show it on Node MCU. So that kind of LED is not required because you don't want to have so many LED because they consume some power, and you don't want to be out of power, right? Especially in certain scenarios. We'll talk about those scenarios. So another form or other actuating entities that you can talk about is, say, for example, motors. Let's say that you have created a smart home and where you are sensing the light. We have PIR sensors, which are light detecting sensors. Excuse me. And what these PIR sensors does is they are able to detect if some light falls on it and they change their state. So you come to know that okay, the sunlight is up. So what would you want to do? You would want to open your curtains, right? So that is one of the implementation of IoT in home automation, right? And opening that curtain or opening the curtains of house is done by a motor, right? There must be a small motor which will be running and opening the curtains. And
mm-hmm.
that again is your actuating entity.
Yeah, that makes sense.
Yeah. Now, another very important stuff you should take in account when you are creating an IoT device. There are a lot of things that you need to take in account. One, the cost, to be honest, right? If you got a project and if you have some budget constraints that your IoT device or prototype or a final product should not exceed $2 or $3, then you should first analyze the components on the basis of your budget. Second, you should talk about the performance, right? And performance mainly comes with your microcontroller. So you have to be very smart while selecting the microcontroller. So you have to go through a lot of prototyping, right? Uh, Creating an IoT device requires a lot of prototyping, right? You simply don't create one and it's ready. You simply test it, you do a lot of testing on it, then you decide, okay, if this combination works or not. The combination of sensor, communication of communication entity, and actuation, and how everything is handled by your microcontroller. Okay, so these are a few of the things which matters a lot. Apart from that, form factor. Apart from that, the sensitivity of your sensors, your microcontrollers. Apart from that, you can have number of pins that is there on your microcontroller. Because let's say that we have to connect 10 sensors, so your microcontroller should have that many pins to support your sensors, right? So when you create an IoT device, you take in account all the things from different perspective. Again, it depends on your use case. And most of the important thing that you take in consideration is what architecture and what protocol you should be going by. That is something which is very much important, right? So the rule that I would suggest is both the protocol, HTTP and MQTT, are very good. And apart from that, we have a lot of different protocols also, like CoAP, XMPP is there. There are a lot of different protocols which are there in the market. But the majorly used one are HTTP and MQTT. So what you would want to do is you would want to decide which protocol you should be going by. What I'll suggest is if your IoT device is going to be in a home, if your IoT device is going to be in a factory, or if any area where you have proper supply of internet and you have proper supply of power or energy to your device, then you should go for HTTP protocol, because now you don't have to worry about your battery dying. You don't have to worry about the size of the data that you're sending, right? Okay. And if the numbers of devices are less, then you should go for HTTP. Why? Because you are going to send a lot of, not much of your data to the cloud or to the gateway, and you don't have to worry about the size of the data, right? You can easily pass that data and you can get the values. That is one thing for HTTP. um, the scenario where you have your device which are solely working on a battery, and in an environment like you want to keep your device in a forest, say you
Mm-hmm.
want to keep it in Amazon, right, rainforest,
Yeah.
and you simply want to monitor the environment there, you want to see the flora and fauna, you want to monitor those things, and in that case you won't be able to go there every week or even every month. You might be going there once in a 6 month. In that scenario, you cannot and you should not rely on HTTP protocol. You should go with MQTT protocol. And apart from that, if you don't want to go with MQTT protocol, then you can go with LPWAN, right? Depending on how you're creating the structure. But I'll suggest to go with MQTT protocol because the size of data is less, and apart from that, it consumes very less battery, so your battery life will be more. And I know few of the tests which are being done on LPWAN, um, involving your NB IoT, if you have heard about this, that is narrowband IoT, or LTEM, that is long-term evolution machine or mobile communication, LTEM, or machine communication. These
Mm-hmm.
are the protocols which are solely or majorly created by cellular companies, right? Like your all the Verizons and AT&T, or we have Airtel and Idea. So these companies, they have created these, or they are supporting these protocols. And what's the best thing about these protocols or using them is that your device on a certain battery can last for 10 years at least.
Wow.
Yeah.
That's crazy. That's good.
Yeah. So that is the power of a right communication entity and right microcontroller, and selecting the right, you can say that, components of your IoT device. Another
Yeah.
use case where you would want to have MQTT protocol or LPWAN protocol. Again, LPWAN consumes very less power. Cellular consumes a lot of power. Is basically you want to have a controller in Sahara or desert or something somewhere like that. You should go with PubSub architecture or MQTT or LPWAN communication.
Nice. Cool.
Okay, so let's talk about what we are building. So, and what we are going to use for that, right? So, first of all, we might not be able to complete this today. So, I'm going to complete till a part where we all are comfortable in doing, and then we can continue it in the next part, right, Michael?
Yeah. And by the way, we have less than 15 minutes in the episode, so that might sway what you can accomplish.
Okay. So, what we are going to use in today's example is basically we have Node MCU, right? Now, Node MCU is has a microcontroller which is called ESP12E or ESP8266, which is basically a family of microcontrollers belonging to ESP series. And this microcontroller has one very amazing thing, that it also has inbuilt Wi-Fi, right? So you can see on your screen, this is your microcontroller, okay,
Hmm.
ESP12E, and it has this antenna that is etched on it. You can see the shape, right? Like a snake,
Yeah. Cool.
okay. And these are the pins it has, and it is quite small in size, and it consumes less battery, so that is good for us. And apart from that, what we need is a micro USB cable, and you simply have to connect with your laptop, you program it, and then you can, once you have programmed it, you have connected all your sensors and all those things, sensors and actuators, you can simply power this up with a battery using ground and VN. Right, you can have a 12-volt battery, you can connect it. I'll try doing it and showing it to you before the next lecture or streaming or the
Sure.
session, right? So this is what we are going to use as a microcontroller and communication entity. So that covers our two part, and it has onboard LED. So that covers our three components: microcontroller, communication entity, and LED. Now we have to talk about sensor, right? So the sensor that we're going to use is GPS sensor. Okay, so we are going to create a complete IoT device with GPS sensor, onboard LED, onboard Wi-Fi module, and our microcontroller, which is called ESP12E. The connection that I have made for this is simple, right? Okay, before showing you the connection or before talking about the connection, let me show you how to run this. So I'm going to exit this, I'm going to start this, and I'm going to open this. Okay, so there are a few things that you would want to do. First of all, you need to have an IDE, integrated development environment, to basically program it.
Hmm.
Okay, so you need to program it. And the best one for doing this is Arduino IDE, which is again free for all. You can simply download it from arduino.cc website. I'm going to do one thing. I'm going to connect my uh, Node MCU. Okay, so I've connected my Node MCU,
You're
and
saying you physically connected it to your computer.
yeah, let me show you.
Okay.
Okay, so this is one end of the micro USB cable,
Yeah. Yeah.
and this is the another end. I think you might be finding it hard to see because of the background, right?
Well, you know what? But actually, I'm just going to switch our view real quick to a larger screen. So can you do
Okay,
that again?
sorry.
Can you show it again? We have the larger screen up
Oh
right
yeah,
now. So,
sure, sure. So this is Node MCU, and it is connected using micro USB cable.
okay.
One end goes here, other end is going to go into the mobile, or sorry, in the laptop. So this is the
Gotcha.
same cable that we use for our mobile, like micro USB.
Okay. Gotcha.
So
So
I'm using the
now
same one.
you're connecting that. Now I'll go back to the screen that you were on. So now that that's connected, what next?
Yeah. So you need to set this up, right? And how do you set this up? See, first of all, Arduino does not support Node MCU by default. So you have to set up your Arduino to support the Node MCU. Simply go to File, simply go to Preferences under File, and here it's going to open a page. And if you want to support boards like Node MCU, you simply have to copy and paste this link. Okay, I've already done that here. So this is a link that you have to copy and paste. What it does is it's a JSON link. It gets all the images, virtual images of ESP8266 base board, and Node MCU is based on ESP8266. So Node MCU is a name given to this board. Okay, and you simply have to paste it here. Click on OK, and that takes all the data. And after that, you simply have to go to Tools, and you have to go to Board Manager, and you have to search for ESP. Okay, you have to wait till it download all the platform index.
Oh, sure. I see that now. Yeah. So once that's finished downloading, then you'll be able to do a search for what were you calling it again?
ESP8266.
Oh, okay.
So I already have downloaded this. So
Okay.
all you need to do is you need to download it, right? And simply click on install and it will be done. You don't have to select the version, right? Close it. Now you'll see one of the very interesting thing. When you go to tools and you go to board, you'll see a lot of different board. So the
Mm-hmm.
point here is, Michael, that if you are a novice developer like me when I started, right? I'm still novice, a rookie developer, and you want to work with microcontroller. If you go and buy a microcontroller, you might not be able to work because it has 100 legs. So you imagine a microcontroller this small,
Mm-hmm.
and it has 100 legs, 25 legs on each vertices, each sides.
Sure.
You won't be able to figure out which legs does what, which leg is for power supply, which leg is, or which pin
Sure.
is for connecting your sensors and all those things. So what you need to do, instead of going for the microcontroller, what we do is we go for a prototyping board, right? Prototyping board are basically board which makes our life easier. It has onboard, uh, let me show you. It has onboard microcontroller. If you can see it, this is a prototyping board which has onboard microcontroller at the center. Now I
Okay.
don't have to worry about all the other things. I simply have to connect this and connect my sensors and communication entity. I'm good to go. I don't have to worry about anything. So if you are prototyping, always go with prototyping board. That would be a very good way to start. Even for new learners, it's quite easy and you get a lot of resources online. So now you'll see there are a lot of different Arduinos here, like Mega 2560, which I have, which I just showed you. It has a microcontroller called at Mega 2560. If you scroll down, then you have the section here you have Node MCU, Node MCU point 0.9, Node MCU 1.0. So we are going to work on 1.0. Okay, so this is the Node MCU that we have. Select that.
Yeah.
Apart from that, you want to communicate with this, right? So it has to have some port to communicate with this, and that port is what we call virtual port. Simply see if you are getting this port, or if you're not getting this port. If you're working on PC, go to Device Manager.
And we're about 5 minutes away, by the way.
Yep. And you'll see that this is the port. This is what we call Silicon Labs, and simply you have it. Now I'm going to show. I think I'll be able to show a Blink example just
Okay.
to let you know how it works. Okay. Simply, there are a lot of examples that you can use. You can go to File, Sketchbook, or example, sorry, and go for basic example. Let's have a Blink example. Okay, so this is a Blink example, and you don't have to worry about the code, right? It's a code which is blinking an LED or switching on LED for 1 second and switching it off for another 1 second. I'm
Mm-hmm.
going to simply upload it and let's see what happens. So I'm going to disconnect all the things from here. So right now it is getting compiled, the code, and then it's going to start uploading it. Let me know if you see a blue LED glowing on this.
Let me switch our view.
Okay.
I'm going to switch our view here. I do see a blue blinking light. Yes.
So that is a very simple example of connecting your uh, prototyping board with your laptop and getting started. Now, guys, we won't be able to show the GPS communication because we require some time for that. So that's
All right.
something that we want to cover in the next session,
Cool.
right? But let's talk about what we are going to do, okay, or what we are intending to do in here.
Okay.
So, what we are intending to do is to create a complete end-to-end ecosystem where we have our end device, right, which is your IoT device, and then we are going to have Raspberry Pi as a gateway. Then we are going to use AWS IoT as cloud server, and we are going to create some user interface on our laptop where we are going to get the data from IoT device to the gateway to the cloud and to our user interface. In doing so, I'll show you one without AWS how to send the data, and then I'll show you example of AWS free RTOS. But I don't have a microcontroller for that, so I'll show it to you on the PC only. And then on the IoT gateway, we are going to send the data from device latitude longitude to our IoT gateway, and we'll see how to store data there, how to perform analytics there, and how to show it on a map, and how you can run an AWS Greengrass there. Right, that is something
Mm-hmm.
that we will see. That will be you can perform machine learning also, but we
Sure.
won't go in there. And then on the cloud, we have to see about AWS IoT, right, where we are simply uh, getting the data, showing there, and we can do a lot of stuff. And then on the user interface, we are going to see on the map what our device is doing, right? So that is something that we are going to build in the process.
Nice. Well, I really appreciate you covering over that architecture. I really did actually learn a few things that I was not aware of with IoT and devices. Some of the protocols you mentioned, and clearly I was fascinated with that long range communication that I hadn't heard about before. So I think that's awesome, Vidhan. And so you said, just for a teaser, so 2 weeks from today at the same
Yeah.
time, what we'll kind of start off with, you're going to do what again?
So in the next one, we are going to complete our IoT device, and then we are going to send this data to our IoT gateway. We are going to talk about IoT gateway.
Okay, perfect.
Yeah.
Well, awesome episode. Very excited to hear the next one. Now, here's some other things that you might be interested in. Tomorrow, for those who are in the right time zone for it, the Americas evangelists are going to do a home office hours. That will be 1 p.m. in the Pacific time. So if you're interested in that, it's actually going to be, ironically, it's going to be a discussion on supply chain, but
That's awesome.
it's going to be a little different. It's not going to be as techy, but it is definitely going to be like the thought leadership of supply chain, and that's actually not going to be by me. I'll be on the show, but Sina will be the one who is going to be covering that. And then 1 week from today will be episode number 2 of our supply chain for AWS connections. And I'm looking forward to that because that's going to be all about transportation, the transportation piece. So I'm kind of approaching it from a use case scenario. But the things we're going to cover in there is simulating kind of what you're building to some extent, simulating a driver with a GPS location tracking, and how we can use that in our overall architecture of getting a product to a consumer in that last mile scenario that we're creating there. So very cool. So we got tomorrow, we got next week, and then 2 weeks from today we have your next episode. I'm really excited about it. So you have anything else you want to say before we sign off?
Just that, stay safe and watch out for our episodes. And that's all. Thank
That
you,
sounds
everyone.
good. Thank you, everyone. We'll see you next time. Take care.